so maybe it'll be good for him.
Yeah.
Maybe. Hunter likes coming over here. He likes it. Of course, he had to ride the bus over here
What do they
in the afternoons anyway.
There's like PE or chorus?
Yeah, PE, chorus, art, band, all those classes. All right. Okay. Exponential and log graphs. So, in this picture here, this graph is y equals 10 to the x power. This graph right here is y equals log x. Oh, I'm sorry. The x should not be that looks like a base. Let me. Over here, this is y equals e to the x power. And this graph is y equals natural log of x. So, I've graphed these together to show you some of the properties that you're going to see of exponentials and logs. Exponentials and logs are inverses of each other. And whenever we have inverses, whenever we look at their graphs, they are going to be symmetric about the line y equals x. So y equals x is just the line that splits the first and third quadrant in half there, like that. So this line right here is y equals x. So if we flip y equals log x over the line y equals x, we'll get y equals 10x, or 10 to the x power here. So they're symmetric about that line. Same thing over here for, oh, sorry. Copy that. Same thing over here for this graph. These two are inverses of each other, so they are symmetric there. So I'm going to write down here since, well, let me make sure I don't have it on the next slide. Sometimes I forget one. Yeah. Since exponentials and logs with the same base are inverses, they are symmetric about the line y equals x. And if you remember this about inverses, what that means, when we have inverses, we switch our x and y coordinates. So if you look like right here on this graph, you have the point 1, 0 on the red graph. If you switch those, 0, 1 is on the inverse of that on the blue graph. We'll talk more about that later, but that's a feature that we have there. Same thing happens over here. And it would be the case with every point. It's just that one is the only one that's really easy to hit grid lines here. All right, so, some key features. So, remind me, domain, what does domain refer to? X-axis. So, it is your possible X values. And if Coach Wood was here, he would somehow go from X values to X's living in Texas, to Dallas being the capital, or Dallas being in Texas, which is a D, that is domain.
And then he'll make A1.
And then he would sing, all my X's live in Texas. So, If we say it too loud, he'll come down the hall and sing it to us. I mean, good song, though. All right, so range is going to be our possible Y values. It's a little like, I don't know if you guys watch The Office, but that episode of The Office where Michael does the name word association so that he remembers people's names, and it's all this like offensive stuff that he says about them, which I'm not going to repeat because it's all offensive, but hilarious. Similar. That's about the same thought process Coach Wood uses to get from X values to domain. There might be some similarities there. Okay. All right. So, so domain and range. Domain is possible X values. Range is possible Y values. So, for this first one, if we graph Y equals 2e to the X here over in Desmos, and you can see it here, but you can also graph it on your screen there if you want. Let's see if it'll let me. No. Okay. All right. So for this, what we're looking for is the X values that we could plug in. Okay. So with an exponential, it looks like I've got what we call horizontal asymptote here. You guys have heard that phrase before, horizontal asymptote. So what's happening over here is it looks like we're getting closer and closer and closer to that line, but never actually crossing it. It kind of looks like we have a vertical asymptote here, right? So I'm going to say it looks like maybe X equals 2, but if not 2, X equals 3 maybe. Right? That looks like a vertical asymptote, but if I go up far enough, it crosses. And what we're going to find is that's going to be the case for all exponentials. Okay? So, in this case, I don't have any vertical asymptotes. This graph, it is doing this. It starts over here. It goes up in this direction forever. It keeps going to the right a little bit. Even though it's really, really, really steep and may look like it's never going to get to 50 over here, it will eventually, although it's really, really large values. So my domain for this is going to be all real numbers. Mathematicians don't really like words very much, so we try to make symbols to replace words so we don't have to write them. So you may or may not have seen this symbol right here. It's an R with a double bar there. That means all real numbers, so you can write it instead of all real numbers if you want. Or if we're using interval notation, like you guys looked at last night, what interval would we use for all real numbers? Negative infinity up to positive infinity. Okay? Let's make ourselves a note right here. A note. Domain of an exponential is always all real numbers. Okay, so that should always be the case. If your base is a 7, if your base is a 10, even if it's flipped upside down, there would be an exception here, maybe if you had something weird like y equals e to the square root of x. We're not going to be going into that sort of stuff. That is not really like just a basic exponential anymore. So when I say always, I'm talking about, any base to any power, but not having weird stuff in the exponent there. Let's talk about our range. When we talk about range, we're looking at the y values here. Let me get rid of this. So, the y values here do they have a limit? Do they keep going down? I can tell right here, this side, it goes up, 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 up forever. So that's making me think that goes to positive infinity there. What about over here on this side? Is it going to go down? Okay, it never goes below 0. I guess technically it is going down forever, but it has a limit of how low it's going to go, right? Because it is decreasing as it gets closer and closer and closer to 0, but it never is going to go below 0. So, our range for this is going to be y is greater than 0. Should I use an or equal to? No, because it doesn't touch that line. It's going to look like it does on the graph because we cannot see that it's 0.000001 away from 0, right? But it doesn't actually ever touch that graph. So we could say y is greater than 0, or interval notation, how would I do this? Okay. Now, with infinity or negative infinity, we always use a parentheses. Should I use a parentheses or a bracket over here? Parentheses. Parentheses is the same as greater than or less than. Okay. Brackets are going to be like greater than or equal to or less than or equal to. So if the point is included, if on the graph you use a closed dot, if it actually touches that point, you're going to use a bracket. But if it is not included, which is going to be the case most of the time with our exponentials, we will use a parentheses. I will go ahead and tell you, for exponentials and logs, because they have asymptotes, if you have a vertical or a horizontal asymptote, that's going to be a parentheses. Because when you have an asymptote, you never actually touch that point. So we won't see a lot of brackets today. They will show up when we do some different types of functions there. All right, let's look at a log. So the log that we have here is y equals 5 log. Oh, let's see. To type in logs on Desmos that have different bases, how do we do it? Let's see, it's in the functions menu, I think. Yeah, there we go, log base A. Log base 3 of x. Okay? Alright, so if we're looking at this graph here, for our domain, we're looking at possible x values. Are there some x values we're never going to get to here? Anything left of 0, we don't ever actually get there because logs are going to have vertical asymptotes. Okay? So our domain for this one is going to be that x is greater than 0, or if we use interval notation, 0 to infinity. Because this is a vertical asymptote and we're not actually going to cross that line, we want to use a parentheses here, not a bracket. I'm going to be giving answers in both inequality notation and interval notation. If I give you a question and I don't specify, you can give me either one. You don't have to give me both. But you need to be able to recognize both. Because what you're going to see is a lot of the questions that I'm going to give you are going to be multiple choice. So on some of them I might use interval notation, but on others I might use inequality notation. So it could be either notation used there. So you need to be able to recognize both. Alright, what about our range? Y values. It seems pretty clear that this goes down forever. Right, we've got a vertical asymptote there. That's that graph. Sorry. That graph is going to just continue to go down down forever. So that is going to go down to negative infinity. Does this graph look like it goes up forever?
Yeah.
Pretty much. Sometimes, especially if you zoom out a lot, it might start looking like there is a horizontal asymptote because the same way the exponentials increase really, really rapidly, whenever that's flipped, logs are going to almost look like they have a horizontal asymptote, so you got to be careful with what the graph looks like. But this is going to increase forever because you start off really steep right here, and then it sort of flattens out, but it is increasing forever. So the range here is going to be all real numbers or negative infinity to infinity. And let's make ourselves a note for this one. Range of log functions let's see, I guess let's try to be somewhat grammatically correct here, of a log function is always all real numbers. Okay, so if you're asked for domain and range here, barring something crazy, which I'm not going to give you right now because we're just looking at basic log and exponentials, you're always going to have a range of negative infinity to positive infinity. For exponentials, always a domain of negative infinity to positive infinity here. Okay. All right, X-Intercept and Y Intercept. So X-Intercept and Y Intercept is something you do as early as Math 1. So for a lot of you, that was in 8th grade. A few of you maybe had it up here with us. But if I want to find the X-intercept of a graph, what can I do? Okay, let's think about X-intercept of a graph. If I have a graph over here, all right, right here, X-intercept is just the place where it crosses the X-axis, right? What's my Y-coordinate? 0. If I change this and put a +9 right there, it's going to change where the graph is at. At my X-intercept, what's my Y-coordinate? 0. If I put a -2 right here, changes my graph again. What's my Y-coordinate? 0. So anytime you have an X-intercept, your Y-coordinate is 0. So we can plug in 0 for our Y. So how do you think we find the Y-intercept? Plug in 0 for X. Now, sometimes it's given to you on the graph, and if it's one I've let you use Desmos on, you're going to be able to just look at the graph and you can find it, especially because Desmos is so nice because you just point and it shows you what the value is. So if I've let you use Desmos, that's perfectly fine. There will be some of these that I might not allow you to use Desmos on. Okay, so let's do this one. I'm going to type it in. We'll look at the graph and then we'll see how we can do it also. So 6 natural log of x minus 4 here. All right. Okay, so for X-intercepts, I can tell that I should get 5, right? So we would have, if I want to find X-intercept, I'm plugging in 0 for Y. So let's say that we didn't have Desmos on this. We would do 0 equals 6 natural log of x minus 4. All right, so if this shows up on the calculator, well, this would not, you won't have a calculator inactive section of the test or quiz. What you'll have is one where you can only use the handheld calculator versus there might be sections where you are allowed to use Desmos on a few of these questions. So right here, this could show up either place. If it's Desmos, just type it in, get your answer, move on with your life. Here, though, if I plug in 0 for my Y, then I could solve this equation. So this gives us a little practice about solving an equation. Macy, what would I do first to solve that equation for X? I do need to do that, but first I've got the 6 out here. I could, but it's easier if I just divide it off right here. Okay, so you could put it in as an exponent, but then you're going to have something that says 6 power to deal with. So if you just divide it because it's multiplied by that natural log, you'll get 0 equals natural log of x minus 4. Then we're going to do the e to the power. Okay, so we'll do e to the power here and e to the power here, which will cancel that natural log. What is e to the 0 power? 1 equals x minus 4. Add your 4, and you get 5 for your x. So algebraically, that's what we do there. So our x-intercept would be at 5, 0. Okay. For the y-intercept, we'd plug in 0 for x. So y-intercept, we would do y equals 6 natural log of 0 minus 4, which is 6 natural log of negative 4. And what do we get when we do 6 natural log of negative 4? Oh, yeah. 6 natural log of negative 4, undefined. Why is that? We're taking natural log of a negative, and we can't do that. So, if I look at my graph, is this ever going to hit the y-axis? I think I have a vertical asymptote here. It looks like a vertical asymptote. So it looks like it's never going to hit that axis. So, for our y-intercept, because we're getting that error, we would say none. There's not one for this. Now, sometimes we get an answer there. It just depends. It would. I know that in this case, none is the correct answer because of what the graph looks like. The answer to why we can't do that with the exponent rule, that I'm not sure about. Because negative 4 to the 6th power would be a positive number. I'm sure there's a reason. I don't know what it is. So, in general, just don't pull those in as exponents. If you're seeing a natural log or a log of a negative, just go ahead and say, no, that can't happen. So it's none for that, because that's going to get you the right answer on these problems. Why we can't do that, I don't have a really good answer for it, but I will try to think about that more and maybe come up with something. Okay. All right, so x-intercepts, y-intercepts, that's something we're going to look for. Positive and negative. Okay? So when a graph is positive or negative, if it is positive, its y coordinates are positive. And if we have positive y coordinates, where does that put us on the coordinate plane? Like, what quadrants do we end up in if our y coordinate is positive? 1 and 2. It's above the x-axis, right? So whenever we're looking at our graph, we're going to see that as the line is above the x-axis. Okay? Negative, our y coordinates are negative. And so that is going to be below the x-axis. Okay, so let's look at this graph that they have given us here. So we've got f of x equals 2 log base 8 There's a way to get it to go. Anybody know the shortcut for typing that in? I want to say some kid showed me a shortcut for typing that log in the class to go to the subscript, but I can't remember it. I think there's a shortcut. Either way, go to functions, it's there. All right, so this is our graph right here. Now, anytime you're talking about positive or negative or increasing or decreasing or those sort of things, think of domain first. Oh, it is. Thank you. Let's put that there. Okay. All right. That will totally change our answer. Okay. So we want to think of domain first. So if I look at this graph, okay, what is the domain for this graph? It looks like we got a vertical asymptote here. Where does it look like it is at? Looks like it's at -1. So it appears that the domain of this graph is -1 up to infinity. I can know for sure that it is -1 because what starts giving us a problem when we're taking logs? What can we not take a log of? A negative or 0. Okay? So this stuff right here, inside of my parentheses, it has to be greater than or equal to, or no, sorry. It's got to be greater than 0. It cannot equal 0. So if I say x plus 1 has to be greater than 0, and I subtract that 1 from both sides, x has to be greater than -1. Okay, which is -1 to infinity. Now, that's not our answer, that's our domain. Because you have to think about domain before you can answer where the function is positive. Okay, so if I think about this graph, let me actually, I'm going to export it and put it over here. Let's shrink it a little here because it's large. Okay, so if I think about this graph right here, it is going to be positive. It's above the x-axis right here. All right, that's my positive section. So what I need to do is I need to think about the x values where that occurs. When you're thinking about x values, think about drawing in some vertical lines to section off that area, right? So that vertical line, if I add it in, let's make it dotted in a different color. That did no good. Come on. Dotted. Green. Okay. So if I have that vertical line there, and then I want to think about, if I'm sectioning that off, there's a vertical asymptote right here at -1, right? So if I draw those vertical lines, it encloses that whole area. On Desmos, you can actually just type them in, x equals -1 and x equals 0, and you can see that that red and blue line, they section off that area that's above the x-axis. Okay, so when you're answering these questions, think about vertical lines, where are those at? So for this problem, for positive, we would say from -1 to 0. You want to use parentheses for both of these. Now, does it actually touch 0 right here? We cross through that point, right? There's not a vertical asymptote there. We don't include it because is 0 positive? No, it's not negative either. So for positive and negative, you will not have a parentheses at whatever that X-intercept point is, because it equals 0 there, which is not positive or negative. So in general, for these, stick with parentheses mostly, and you'll be good. All right, so negative. I should be writing this way. If we're doing if we're doing inequality notation, to say that something's between two numbers, we're going to say -1 less than x less than 0. Always write your lowest number first. Use less than signs. Put your x in the middle, less than, upper number. Okay. I'm using just less than signs for this because I have parentheses. If I had brackets, that's where I would use a less than or equal to. All right, from negative, what do you guys think? Okay, 0 to infinity is what I hear. Do you guys agree? How many of you think it is 0 to negative infinity? Okay, you're wrong. You're terribly wrong. I know you're wrong because interval notation, this is terribly wrong because the lowest number always has to be first in interval notation. So if you see yourself writing something and your lowest number is last, you've done something wrong. It doesn't matter what the question is. It doesn't matter what you're answering about it. It doesn't matter if you got your numbers right or not. If you see yourself, like if I see somebody write that the answer is 2 to -3, and this is interval notation, I know they're wrong. Because interval notation, your lowest number always has to be first. The reason you guys are thinking negative infinity is because that y value is going to negative infinity, right? Because the y values are decreasing here. The line is going, if you're thinking about up or down, you're thinking about the y value. When we answer these questions, we're asking the domain where this happens, the x values where this happens, right? So what we want to do is be able to put vertical lines around it. And so those vertical lines, the vertical line here would be at 0. The other vertical line we can't really draw. Oops. That line right there. This other vertical line, let's say theoretically we could ever make it over here. Positive infinity would be way over here on that x-axis, right? We'd put a vertical line there if we could ever theoretically get to infinity, which we cannot. But so we got to think sectioning this off, reading it from our x-axis. The only time your values should come from the y-axis is if you're talking about range, because that is y-axis, right? Otherwise, we got to think about the x-axis. And so from 0 right here on the x-axis to positive infinity on the x-axis, we see that that line is below the x-axis for that, so it's negative. So it would be 0 to infinity for this, but it is a really common error for me to see 0 to negative infinity because you've started to look at the y values there. It's easy to get it mixed up. So we could also write this as x is greater than 0, all the numbers bigger than 0. Okay, questions? All right, increasing and decreasing. Okay? Increasing is going to be y values increase. I know it's bad to define a word using that word, but we're going to here. Increase, the y values increase from left to right. So the function will look like it's going up. Right, from left to right, your y values are going up. Decreasing is going to be y values decrease from left to right. Going down. Okay, here's some good news about these. logs and exponentials are either always increasing or always decreasing on their domain, right? So, so we should not have places where it's increasing and where it's decreasing for these. Whenever we get to other types of functions, we will. Parabolas, they increase and then they decrease, right? So, but this section we're working on logs and exponentials. So if we look at g of x, equals 3 to the negative x power. Okay? All right, so is this graph, we'll always start on the left side and move to the right side, is this graph increasing or decreasing? Decreasing. So this is decreasing for, and then we need to know the domain of this function because it can only decrease on its domain. What is the domain of this function? Negative infinity to positive infinity. Exponentials, their domain is always negative infinity to positive infinity. Even though maybe it looks like it might have a vertical asymptote there, if you check it out more in depth, it does not. Right? Exponentials are going to always have a domain from negative infinity to positive infinity. So this is always decreasing for negative infinity to positive infinity, or you could use all real numbers for that. Okay? It does not increase at all, so we would not put anything for it increasing. Or if there is a blank for increasing, you just put none there. All right, let's look at the log. Log, I've got negative 6 log x plus 4. Well, let's zoom out a little bit on that. I can't see much. Okay. Is this graph increasing or decreasing from left to right? We're decreasing again, so it's only going to be decreasing. Okay. But this time, it can only decrease on its domain. Is this graph defined over here at negative 3? We got nothing, right? We can't see the graph even if we zoom out. It's not going to be there because we got a vertical asymptote. So it cannot decrease where it does not exist. So we have to say it's decreasing on whatever its domain is. What is our domain here? It is 0 to positive infinity. Again, it might seem backwards to you to say 0 to positive infinity whenever it's going down to negative infinity. But when you start thinking it's going down or it's going up, you're thinking y values. That's not what we report. We're thinking about right here at 0, all the way on the x-axis over here forever, which is positive infinity. We see that this is decreasing. Or we could say 0, actually, you can't. I was about to write this. Don't do that. Don't put infinities in inequalities. How would I write that with an inequality? X is greater than 0. Okay. Questions here? Yes?
Okay, so why would it be infinity instead of just 2? Because that's where it touches.
Okay. Good. So we're talking about increasing or decreasing, which doesn't have anything to do with positive or negative. Okay. So it doesn't matter if it's above or below the x-axis. So as long as we are still decreasing, it doesn't matter if it's positive or negative. If they had asked us for where it was positive, we would do 0 to 2. Or if they had said where it's positive and decreasing, they might ask you for 2 things about the graph. It'd have to be 0 to 2. But if it just says decreasing, it doesn't matter if it's above or below the x-axis. Okay. All right. Other questions? All right. Concavity. Concavity is the curvature of the graph. And if you have something that's concave up, it's curved upward. I know that's not a great definition either, but we're going to draw some pictures. The most common concave up is think like a U shape. For logs and exponentials, it's either going to look like this or like this. It'll be only like half of the U, right? So we would say those right there are concave up. It's like a upward part of an upward facing U. Concave down is curved down. Word. So think of it upside down U. For logs and exponentials, that looks like this. Of some sort, right? It's like either half of that U. Okay. Good news about concavity. Logs and exponentials are always concave up or always concave down on their domain. So when you see this, it's really just asking you about their domain, more or less. And you got to decide if it's concave up or concave down. So 2 log of, I'm going to use x minus 1 so it'll graph it better. All right, is this one going to be concave up or concave down? This one's down, right? So we would say concave down on the interval, and we need our domain. This one is not concave down at -7 because there's no graph at -7, right? Where is our vertical asymptote here? 0, 1. How do I tell? Oh, and then sometimes your graph will do this. It'll stop. It really didn't stop. It just got to where Desmos couldn't handle it anymore, is what happened. It doesn't really have this gap right here. It doesn't really stop right here. Desmos, just for whatever reason, couldn't handle those numbers, and it did this weird thing, right? It just had an issue. So it looks like it stops, but it really didn't stop. So how can I tell for sure if it's 0 or 1? Look at whatever you're taking the log of. That must be greater than 0. Okay, so whatever you have here for your domain, a minus 1 must be greater than 0, which means a has to be greater than 0. So this would be concave down on, they use an a instead of an x for their variable here, so you could say a is greater than z. I'm sorry, that's not right. What is it supposed to be? Not 0. I wrote the right thing and then didn't even add my 1 over here. A is greater than 1. So a is greater than 1. Or you could say 1 to infinity. The good thing about this is when you do the homework that you're going to have for this, you are going to find the domain first. So when you find the domain, then you just can use the domain for your answer for a lot of the other problems there. Okay? All right, asymptotes. Okay? For a vertical asymptote. Okay? Vertical asymptotes. As x approaches your value, y coordinates are going to approach plus or minus infinity. So as you get closer and closer to whatever x value you're dealing with, you're either going to go up to infinity or down to negative infinity. Okay, so let's say that we have a vertical asymptote right here at 2, right? So if you have a vertical asymptote there, what's going to happen to the graph is as you get closer to 2, you're either going to go up to positive infinity, or your y values might go down to negative infinity. It could be either one, right? So those numbers just get the skyrocket where you never actually touch that 2, or they plummet where you never actually touch 2. Okay? Horizontal asymptote is different. Okay? It's basically like we switch those two things. So as y approaches either positive or negative infinity, it could be on either side, x approaches some value. So the way that this looks, hold on. No, I've got that backwards. I didn't need to switch x's and y's. Sorry, redo. I need to switch. As x approaches positive or negative infinity, y approaches some value. I switched the wrong things there. So what that means, if I'm talking about where x equals infinity, that's way out here, right? And x equals negative infinity, way out here. So if I have a horizontal asymptote, say that it is at 1 right here, as my graph goes out towards infinity over here, I get closer and closer to whatever value that horizontal asymptote is. In this case, it's 1. Over here, you could also have the same thing in the negative direction. Okay. All right, so we've got -3 log base 3 Okay. All right, so I've got this graph. I'm supposed to describe the asymptotes. Okay. Do I have a horizontal asymptote? Be careful, because if you zoom out enough, it's going to look like you do. But horizontal asymptote is none, because you're going to see that this does continue to decrease forever. It's not going to get closer and closer to a value. Vertical asymptote for vertical asymptote, what's it look like we got right here? Okay, 7. So that would be vertical lines. What's the equation of a vertical line? It's either x equals a number or y equals a number. Which one is it? It's x equals. And if you're not sure, if you're allowed to use Desmos on this, type it in. X equals 7 is going to give us what we want. If I put a y there, it does not. It gives me a horizontal line. All right. So vertical asymptote is at x equals 7. I know for sure it needs to be 7 because I can look right here, right? I know that 7 minus x has to be greater than 0. So if you add your x over here, 7 has to be greater than x, or that's x is less than 7. So so that tells you where that vertical asymptote is at if you're unsure. A note here, logs always have vertical asymptotes and second note, exponentials always have horizontal asymptotes. Okay, so that will always be the case. It will never have both. So logs do not have horizontal asymptotes. Exponentials do not have vertical asymptotes. Okay, all right. So we'll hold off on end behavior until